Okay, let's start off. Are there any questions about anything that's been going on in here? Any logistical questions about the course or anything like that? Anything interesting in the news anyone wants to talk about? Okay, let's start out. First question is just a quick review of how people are doing on this week's problems. How many people have got all 4 of this week's problems done? Okay, 1. Okay, how many did you have done before the week started? 2. Okay, so you did 2 more. Okay, how many people did have done 3 of this week's problems? Okay, 1. Okay, 2. So how many people have done 2 of these week's problems? Okay, a bunch of people. How many people have done 1 of this week's problems? Okay, how many people have done none of this week's problems? Okay, so for those with none of this week's problems, those are the ones I want to chat about quickly. Any particular reason why not? One possibility would be I didn't do anything. Another possibility would be I had problems. What was the thought? Which was the explanation? Doesn't accept your answer. Okay. You did 1 question? Okay, so you're busy with other things. So what about you?
Just rested this Monday, so I just finished the last week question, last 4 questions.
Okay, that's good. Okay, so it's good to keep, again, I encourage you to keep up with the 1-week cycle in that it's bad to obsess too much about last week's questions. It's good to sort of, when I give you a new week's problems, try to get started on those so we have something to talk about in here. So you can do the serious reading on before the next week. Okay? So that's the flow I want to hear. Sounds like a lot of people got a bunch of the problems. Let's go through, let's think how we want to do this now. What I would probably propose is that we start talking about each of the problems and see if there's any interesting issues with them. Okay? I have some more material I guess I would talk about a little bit on a way on ranking and unranking functions. But let's go talk about the problems themselves. Here I signed it on the website for the the printouts. Now the PDF printouts in English are now there. So if you were having trouble getting good PDF printouts in English, now we have the PDF problem printouts of the programming challenge version of the problem, which I think is better written. The other thing we have here is that we also have it in Spanish. How many people here want the Spanish version? Okay, nobody. Okay, but if you want it, here's the Spanish version. Okay? Any questions about that? Actually, this started a discussion of maybe we're going to try to get the Chinese version and all these other versions maybe someday. But, because the book has just been translated actually into simplified Chinese. Actually, how many people, if you had access to the book in simplified Chinese, would prefer it to English? So here's the question. The book is being translated into simplified Chinese. I know, given me a choice, I would rather read it in English. Some of you probably have different answers, okay? Who would rather see the book in the English version? Who would rather see it in the simplified Chinese version? Okay? Nobody, okay? So I guess get the English version. Okay. Jolly Jumpers. First problem. What is the Jolly Jumpers problem? Someone want to describe it quickly? I think that's the way we would do it. Let's have somebody describe to me what the problem is. Someone with a hand. Okay? You can raise your hand and describe it. Yes?
Just count all the difference between 2 numbers of a sequence and see whether all this differences covers from...
Whether all integers between... so you're reading the numbers from... a stream of numbers, and n numbers, and the question is, you have to test whether or not, as absolute values of differences of neighboring numbers, do all numbers from 1 to n minus 1 show up? Okay, that's the problem. Okay? And how many people got this one? Okay? How many people did not get this one? Okay, 1 person has not gotten it. What kind of problems are you getting? Are you getting wrong answers, or are you getting...
Wrong answer.
Wrong answer, okay? Well, let's think a little bit about this one for a second. Are there anything interesting about this problem? Most people seem to have done it. First question is there, what data structure would you use, it seems to me? We're using a data structure to store store what? Let's think what we need to store as we read this. Are we storing the, numbers themselves, or do we need to store the differences? The differences. Is there actually any reason to store the numbers themselves here? That's an interesting question. How many people's program read in all the numbers, stored them in an array, and then did their thing? How many people did not bother to store the original numbers in an array? Okay? Again, I don't know if it makes a big difference here, but it might be easier depending upon how you read it in. I don't offhand see any reason necessarily why it's actually easier to read them all into an array and then do the differencing. Does anybody see a reason why that's easier? Okay. You may say, well, the whole program's 20 lines long, and so it doesn't make any difference anyway. But that's just one thing to think. How long were people's programs for this? How long was your program?
I think 30 or 40 lines.
30 or 40 lines. Is that about what people came up in? You came in 120 lines. What, 20 lines? Who came in over 40 lines? How long was yours?
70.
70. Okay, why did you use 70 lines for this? Let's think about this.
Because in fact, my program can be more simplified, but I'm too lazy to make it short.
Well, there's a question of too lazy to make it short versus too lazy to make it, to do it, well, okay, the question is, let's think about whether being too lazy to make it short is the right attitude or not. Okay? Because in one sense I would say by measure of typing you did 4 times as much work as he did. Okay? So on a laziness scale, that may not be the right metric. Okay? On debugging, I also find that the number of lines to debug the amount of debugging you do tends to grow linearly in the size of the program. Usually, because you type in bugs at a certain rate. Okay? So just out of why was it so long? It's not meant, by the way, let me start out with this. It's not meant to be criticism. We're working here to try to get better. Okay? So I'm just trying to, as an investigation, why was your program 70 lines long?
I store the input, I store the differences, and I do sorting. I make it very simple and very stupid.
Well, you say simple and stupid are two different things, okay? So the first question, you said you did sort it. Did you use it inline? Whose sorting algorithm did you use? Did you use a library or did you write your own?
Selection sort.
So in other words, you wrote your own, okay? This is not simple to me. This is not lazy to me, okay? It means using a library function is less lazy, okay? How many people who got it working did take the numbers, stored the differences, sorted them, and then cruised through it? That would be a respectable way to do it. How many people did it that way? Is there anybody else who used sort for this? I would say sort is not an unreasonable way to do it, except that you shouldn't be implementing it. You should be using your favorite library sort to do that. Okay? Because for a couple of reasons. One is selection sort. If this program had been how fast should it, as a function of an array size of n, how fast is sorting? N log n. If you do it a reasonable way, how long as fast is it going to be with selection sort? N squared. Okay? So what does that mean? That means on this particular problem, you got away because they told you that that there were at most 3,000 lines. Is that right?
Yeah.
Wait, no, there are most 3,000 input instances. Is that right? No, wait, no. What's it say? The first line contains an integer followed by the number of these things. You got lucky that there were only 3,000 input instances. Is that right? 3,000 squared is what? 9 million? A million of something is a reasonable amount of steps. Computers are fast enough, a million is not a big number. But a billion is a big number for computers. These days, when you talk about budget deficits in the United States, trillion is a large number. Okay? But billion is a large number in terms of what a computer can do. So how big an input might he have been able to deal with his selection sort? It was n squared, right? Could he have done a 30,000 by 30,000 sort? What's 30,000 by 30,000? I can't do that in my head. But I can do 30,000. Okay? And if I want to make it 30,000, multiply it by 30,000, I add 4 zeros, 1, 2, 3, 4, and I redo it. That would have been about 1 billion. Is that right? That looks like that's about a billion, right? So your method, okay, the idea of doing the sort, okay, would not be would selection sort have failed, let's say, by the time you got, if they said n was equal to 30,000. And the only reason n doesn't say 30,000 is that this is an old problem. Computers are probably faster, where 3,000 was a big number then, when they wrote the problem. But if you used a, an n log n algorithm like quicksort, how much time would it take to sort 30,000 things? Okay? If I want to think about it, I'd say 30,000, that's n, times the log of 30,000. What's the log of 30,000?
3.5.
3.5? Depends what base you are using. 3.5, 30,000? I don't think of it. What base are you using?
10.
Base 10. Okay? So a base 10 log, let me make sure I understand. What is a base 10 log? The base 10 log is 10 to the x equals 30,000. Is that right? And is that is that about 3? Okay. Wait a second. 3 would be 1,000, right? 4 would be 10,000, right? So it's about, that would be about 4.5 by base 10 logs. Usually I think about this in terms of binary logs. What would a binary log be? That you said was about 15. Is that right? Well, 15 times 30,000 is what? I can't do that kind of multiplication because it's, it involves too many numbers, but I can still make it as 20. That would be 6 and add 0. That's 600,000. That would still be fast enough. Does everybody see that? So one interesting thing is your program, you may be saying, hey, it's no problem to write a selection sort. And that's certain that it's still a wasted effort, perhaps. But it's not that hard. And maybe I have it memorized or I have it tattooed on my wrist. And so it's easy for me to type it in. But note that you would still potentially run into problems with speed, which you wouldn't if you did that with a library. Does everybody see that? That is one reason why it is libraries are a good thing. A fast sort can come from a library easily. If I had to implement an n log n sort, I probably couldn't do it in an hour, under an hour or so. Okay, maybe my fingers are slow or something like that. Some of you may think that you could do it faster. But, so that's the lesson here. Okay? Is that you should not be using your own sorting library, algorithm. You should go and use your a library. Do you know what library you would use? What language do you use?
I use C++.
C++. Where is the best way to get sort in C++? Okay, what? Algorithms. What does that mean? Someone will give me a complete answer. Raise your hand. Okay? Okay, so there's the algorithm library in C++. By this, do you mean the standard template library?
Yeah.
Okay.
Use the short A of begin braces. That is the sorting method in the algorithm.
Do you have it memorized enough you want to write it on the board? Come on up, write it on the board. Okay? there's two different ways you could do this in C. If you're an old person, C++, if you're an old person like me, you probably still have access to the QSort library. Is that right?
Suppose I install the numbers in the random shape, and then I will sort it in this way.
And okay, so this is saying that the way that he would have sorted it, he would have used the standard template library, okay, and he would have just simply called sort. It said begin. This is, I guess, what the first element that you want sorted, right? The index of the first or basically the position of an iterator. The way the first spot is, where the last spot is, okay. And this would have been a much better solution than redoing the other one. Okay? So that's one lesson for today. Okay? Any questions here? Okay? What other things are there? So you said the next thing you just sorted it, and then you just scanned through it. That, by the way, to me is not a bad solution if you use the fast algorithm, the built-in library function. Why? It's now a question of you read this, you get the integer. For I goes from 1 to 4. Wait. Then first read the first integer. Then for I goes to 4 minus 1, meaning 3. Read the next integer, put the diff in array, diff in the array, diff in the array. Sort them. And then scan is element I in the ith position. That's what your algorithm was, right? That would be a very short program, actually, I think. Okay? If you didn't have to write your own sort program. Any questions? How else did people do this one? Yeah?
I had an array of booleans, and every time I got a difference, I just checked off that index in the boolean array. And so the index corresponded to the difference that I needed.
Okay, so one possibility is, what you did is you set up basically a bit vector. This is what you're telling me that you set up. From last class we talked about one way to represent a subset is to set up a bit vector, right? And you said every bit vector you said was, has this number been seen, it is false, right? And then you did for I goes from 1 to, if you stored the differences in an array. Did you store the differences in the array?
No.
You just used, okay, there was no reason to actually store the difference, right? You read the difference, you immediately used that as the index, you set the bit right. And then you went at the end and you made a scan through the bit vector. Is that right? Okay? That would be one way to do it. Okay? Any questions? Any other way that we might be able to use that same, any variation on that same basic approach that might be a little simpler? Yeah?
If you have to set a Boolean table that is already set to be 1, it means you've got duplicated differences, and then you cannot get the answer.
Okay.
And if you got something out of the table, you already cannot get the answer. And otherwise, you can get a nice Boolean table all set to be 1, and you can just write Joey.
Wait, so let me think what you're saying here. So the question, I think, is a question of how can we go and avoid doing the test, let's say, of the only thing that I get, the only way, this is not that complicated right now. Just for academic purposes, is there a way we can avoid making that sweep at the end through the array? Okay? To test whether or not we had an empty Boolean. Okay? One thing that comes to mind is, if you ever, when you did an insertion, if you ever hit an element that was already true, right? Then at that point you could set the flag to be not jolly. Does that make sense? So you really don't need another loop at the end. You could have a Boolean variable. Maybe this is what you were saying. Okay? You have a Boolean variable jolly Q. Okay? And you set it originally to be true. Then you check every integer. You set every one of your booleans originally to be false. When you read a value, you check, is the value false? If the value is not false, then if the value is false, you set it to be true. If the value is not false, you set jolly Q to be false. And then at the end of this, okay, you go ahead and do that. Okay, any questions? Actually, is there, I guess one other issue. You'd have to make sure that all your integers are in the range.
So you set definitely the table exactly as an integer n, and if you got out of table, it's still you have to set jolly.
So we got an out of table. So the real test here is if the integer is less than 1 or greater than n minus 1, or if the flag is false, set jolly. Okay? And that might be it. The way you're doing it is fine. I'm not really complaining. But it's interesting to think about different ways to solve the same problem. That's, I guess, why I want to talk about the easy ones. Okay? Because there's often easier ways to do it that you get sensitized to, if you think about it. Any other variations on this? Did anybody try anything that's different in any way than anything we've talked about here? Did anybody use a different data structure for representing what integers we've seen already? Okay, I think the bit vector is the logical idea. Okay, or the sorting thing if you call a library. That doesn't offend me if you call a library. Any questions? Okay, very good. Let's look at the second problem now. What was the second problem? The second problem was crypt kicker, right? Boom. I guess we could look at it here, right? So, anyone who wants to tell me what crypt kicker is about? Somebody else who's looked at this problem. Okay? If you've looked at this problem and you didn't get the other ones, this is a good one to volunteer for because I'll keep asking for all of them. Who wants to talk about crypt kicker? Just tell me what the problem is. Somebody. Somebody, okay? I need a volunteer. Yes, you.
Okay. You have a dictionary and you have got some encrypted sentence. Then you need to know you need to find out the decrypt table, which you know which letter maps to decrypted letter.
Okay, so you're telling me that the input here is, again, I usually look down quickly at the input. The input is a dictionary of legal words in our language. There are legal words in English, and an encrypted sentence over these things. And the question is there a decryption of this sentence? Okay? How many people got this one working? One. A few more with slower hands. Okay? Let's think about this for a second. How would we represent how would we want to store the dictionary? Okay? Let's think about this. Seems like part of the issue here is storing the dictionary. Okay? What data structure would you use to store the dictionary? You said what?
Only arrays.
You would say an array of characters.
Array of string.
Array of strings. Okay? That would be one idea. Did anybody else use something else?
Tries.
Tries? You used a try. You implemented a try. Is this because you wanted to frustrate me when I said it was too hard to implement, or what was you?
It's fast.
Okay, so you said you implemented a try and you said it was faster. Okay?
Because I attempted by myself. I know tries before and you see very easy.
Okay, so this is maybe this is maybe the resolution of our dilemma. He's saying that he has already implemented a try data structure before. And so, for the purposes of this, it's not hard for him to implement it because all he's doing is calling it as basically linking it in with his program. Okay? So that's a good solution. That's a potentially reasonable solution. Of course, that wouldn't work on a programming contest because they wouldn't let you into the room with a electronic version of your try library. right? How many lines of code was your try library?
It's not quite long. What, a little more than 30 lines.
30 lines. So maybe what you're saying is you would go in with a printout of your try library and then hack on it. That might be true. I'm still a little bit, okay, let's think about that then. Okay, because let's see which representation is better. Okay? So who got it? Okay, so what do we do now? Now that we've got all these things in, we also have to represent the string, the sentence. How do we represent the sentence? Okay? Any idea?
A string.
What?
A string.
You say a string. Okay, maybe that's sense. Okay? Although, why wouldn't I make that an array of words also? Because it seems to me that this thing is something that you're going to want to access on a word-by-word basis. Isn't that right? So I would guess I'd probably want it at, broken down into words or something.
So you have 1,000 words. So
You're saying I've got 1,000 words in my dictionary.
yes.
And so what's 1,000 words? Is that a big number or a small number?
Okay.
Small.
Small. What's 1,000 words? What's a 1,000 string array? Wait, no, I'm not sure I'm understanding your concern. So why don't you explain it again?
My algorithm is recursion. So if you store all the words in the string, so you need to do 1,000 every time.
Okay. Okay, maybe I'm not yet understanding your solution, but let's keep going on this a little bit. What is the key operation? What is the operation we need to do with the dictionary for this problem? Okay? What is the key operation that we need to do? Okay? Given a sentence to test if it's an encryption, what is the operation that we need to do? Okay?
I
Yes.
think it's here to return a word of a sentence net.
Here, what we need to be able to do, you're saying, is for each one of the words in our input string, you want to return, you say, all the words of that same length, because they represent possible candidates for it. Is that right? So you're saying that for BJ, VG, we would want to return Dick, Jane, Puff, and Spot. Is that right? Okay. So if that was true, how would we want to organize the dictionary?
The table based on the length of each sentence and so on.
You're saying is that what you would want to do is to order the dictionary based on the size of the number of words. I think that basically an array of sets of words. Okay, where all the 1, 2, or 3-letter words are in one set, one array. All the 4-letter words are together, the 5-letter words together. So that you could retrieve them reasonably. Is that what you're saying? Okay. Any questions? I don't know if that's the right answer. Are all the 4-letter words candidates for this first word?
There will be so many 4-letter words. So
You're telling me there's a lot of 4-letter words, okay, in in English. Does anybody, out of curiosity, this is now intended to check. What do people? If I was going to say a 4-letter word, what would people think I mean by a 4-letter word? Does it mean what it means in America? Yes, okay, just checking about that. Okay, good. But which 4-letter words are all 4-letter words candidates for the first word in the encrypted thing? Let's look at this thing. Are Anne, Dick, Jane, Puff, and Spot all candidates for the first possible string?
Puff is not.
Puff is not. Why is puff not?
Double F.
Because it has a double F. Okay? Does everybody see that? So, one possibility, so how would you propose to deal with this thing? Okay? What would you like to be able to do? It seems to me that your real problem that you'd like to solve is given one of these strings. You'd like to retrieve which are the legal words with them. Does that make sense? Okay? So if you would like to somehow have as your data structure, it seems to me that the first issue that you would like to do when you try to identify what the candidates are is you'd like to try to identify which candidates have a similar letter pattern, as it's a question of length and it's a question of repetitions of letters. Isn't that right? So how would we do something like that? How would we identify what the minimal set of candidates are for each spot in our string? Okay? How might somebody do that? How would you propose to do that?
My algorithm is I do it from left to right, and every time I check the target, maybe I should.
You want to come up here? I'm happy to have you come up here. Okay? Here we go. Okay, let's get rid of this. Just leave the source. Okay, go.
So for this example, I have checked every time I check. At first I'm here and I would choose from A to Z to decrypt this character, and if I replace it by A, and this tree is unknown, so I will search the dictionary with this word. So if it is not exists, so I will throw it and replace it by E and do it again.
Okay.
Then if it is possible, I go next.
Okay, so let's think about, do people see what he was saying here? About how he was doing this? A question like, I don't see how he was doing it would be a good question. Any questions? Okay. This question is, this problem starts to get interesting in maybe there's a couple of different issues that seem to be coming up here. One is an issue of how do you search, okay? And this looks like it's basically involving some kind of a backtracking. That's where your recursion thing is going, right? Okay? So there's one question of how do you do a backtracking to search through all possible mappings of the letters A through Z to the letters A through Z in an efficient way. That's really what you're proposing, right? Okay? The other is the question of whether or not there's a better, what is the right data structure to help you discover your candidates. Okay? Those seem to me to be two different kinds of things. Okay? Now, the way that you're proposing to do it is something that you fixed the first, you said you got all the candidates for the first letter, for the first word, right? Did you already have candidates for all the other words also, or just the first one? Just the first one.
Just the first one.
Okay? Would it be interesting here? Why might it be interesting to identify candidates for all the words in the encrypted string at the beginning? Okay, I understand what you're doing now. You're trying to build it one character at a time. and you backtrack when you hit a contradiction.
Yes.
Is that right?
Yes.
What if the word consisted of sentence looked like something like this, where there were a lot of words here that match? A lot of words. Let's say that the word, you have how many words? 3,000 words? 1,000 words in the dictionary? What if every one of them was a 3-letter word? Okay? If you've got, and let's say that that these 3 letters were independent of the 3 letters for the next 26 over 3. How much 26 over 3? The next 8 words.
But every time I replace the character with another, I record this and I hit this I hit this character again, so I will replace it.
That means now the following characters will not appear again.
Right. What happens if the code word I gave you was A, B, C, D, E, F, G, H, I, J, K, L, M, N, O? Okay? You're going to diligently find all 3 words which have 3 letters that are distinct, right? Does everybody agree with that? And now you're again going to find all 3-letter words that are distinct. Okay? This is potentially a problem. Okay? Do you agree? Especially if the last word happens to be Z, Z, Z. Let's say M. Let's say it was Z, Y, Y. And the only word of 3 letters that was of that form was moo. Everybody know what moo is? That's what a cow says in America. Okay? If we added this case, the right way for you to have addressed this problem would have been to find out that there was only one word here that would have matched this one. Do I see an advantage to, first of all, did you get it past, your solution past the judge?
I get solved in both UA and...
Okay, so you got it solved, so I'm giving you a hard time, but you in fact have a wording solution, right? And anybody else have a correct solution to this? You did, okay? How did you do it?
First of all, I hit the frequency string and then pass it to an array of characters, and then I sort it by the length.
Okay, so you found again, for each one of these, you found out which words have the right number of letters.
Yes.
Is that right?
Yes.
And then what kind of filtering did you do?
And then I insert the longest encrypted word to the dictionary and check that whether it is in the dictionary or not. Every time I insert one to the dictionary, I have another copy of the dictionary, and then there is not a matching word, and I roll that to the previous dictionary and insert another.
Okay, so this is backtracking thing, okay, again, that you're doing. Okay? We'll talk about backtracking several weeks from now, okay? But the key when I think about backtracking is it's important that you get your pruning done as quickly as possible. That is what is necessary. The quicker you backtrack, the better off you are, right? And it would seem to me that one way that you could backtrack more quickly from this would be to, one, find which are the find all the candidates originally for each position, right? Prune them out by deleting all the, try to find what is sort of as fixed as possible. And use that to sort of prune things out as quickly as possible. Okay? Or let me, again, maybe I'm still being a little imprecise here. Okay? But if let's say you put down a, if you put down you said over here that B was equal to an A, okay? Then somehow you'd like to figure out, is there any other place where you use a B? Does that restrict the choices of the words to the point where you can backtrack quicker? Would seem like a better idea. You got it working, and so I shouldn't complain. But I do think that there's a speed issue there, potentially. Okay? Any questions? Okay? Any questions about the dictionary data structure here that you would use? Okay? Because, to my mind, it's not clear to me that the dictionary that you guys are using would be the most powerful structure that there could be. You really want to look up for each one of these words like Q, Y, M, M. Okay? What were all the words that ended in a double letter that were of length 4? Isn't that really what you wanted to look up? Okay, as the candidates for here? Could we build a data structure where that might be an easy thing to do? Okay? Any ideas how we might do that? Okay? Let me show you one idea that comes to mind for me that may or may not, by the way, be the right thing to implement here. But just since we like to talk here, let's see if we can figure it out. What if, instead of storing as the key, okay, in my dictionary, the actual words, what if I stored the format of each actual word? Okay? Where what I'm going to do is assign each word a canonical name. Canonical means I want to make each word so that we agree that Jane and Dick are the same word because they're made of 4 distinct letters, right? Where Puff and Jane are not. Is there a way I could make a dictionary of canonical structures here, such that everything gets looked up the same way? A minimal representation, what does that mean?
I replace all the different characters from A to Z. So, like Dick, I made it A, B, C, D. And Jane is also A, B, C, D, but Puff is A, B, C, C.
Now, this is an interesting idea. What if I rewrote that? That's exactly right. What if... what is this? There you go. Okay. What if A and D went to, you say A, B, C, right? And Dick went to A, B, C, D. Does everybody see what we're doing? We're going to number each letter according to its, assign it the letter of its first appearance that it came in, right? Jane would be what by this name numbering scheme? A, B, C, D. What would Puff be? Puff would be A, B, C, C. Does everybody agree with that? Now, what's neat about this? What's neat about this is that it enables you to now group naturally for any one of these type of words. All the words with the same, each one of these is going to have a code in this language. All the words that could possibly fit will map to this. And so you could retrieve exactly what the right candidates are. Does everybody see what we're going to do? We're going to have a dictionary on word structures. And each word structure is going to contain a list or an array of all the words that fall into that category. Does that make sense? How do people understand the data structure that I have, I just described? How many people don't understand it and would like to? Okay? So what's neat about that is, that would be a way to retrieve exactly what the right choices are for each word, right? And now what you want to do, I think, you were trying to build it up on a letter-by-letter basis, as I understood, right? What would be more powerful than building it up on a letter-by-letter basis, it would seem to me, would be building it up on a word-by-word basis. Okay? If you have some of the word, because what's interesting here, in this particular sentence, huff is the only word that has that particular form, right? So in this particular sentence, if you started by looking that this word had only one form, right? That immediately fixed certain letters. It could be that for some of these, okay, that are all of the right form, did we have and would have all been the same form. That would have fixed certain letters, right? By going to the weakest part, the column with the smallest number of words, I would say that that might be the place to fix it more efficiently. Okay? Any questions?
Is it difficult to implement more? Is it more difficult to implement it word by word or character?
Well, is it more difficult to implement it word by word than character by character? I guess let's take a vote. That would be one way to do it. Again, you got yours working and the rest of the class didn't, so I shouldn't be giving you a hard time. Okay? I'm not giving you a hard time. Recognize that. Okay? Is it easier to do the thing on a character by character or word by word basis? Who here thinks it would be easier on the character by character way? You should raise your hand because you're the one that did it that way, right? You think so. You think so. Who thinks it's easier on a word-by-word basis? Okay? About half and half. There's a way to tell is those of you who raised your hands on the word-by-word basis, implement it by the word-by-word basis. And then tell me, we'll compare the number of lines. Does that sound like the right way to tell? That's a scientific way to tell. Okay? Any questions here? But more than that, you see how by using the right dictionary, the dictionary on the right things, we were able to retrieve the thing we needed. Okay? Whereas it's less clear to me that the other thing is what you needed. Okay? Any questions? Okay? Any questions about that problem? Okay, go off and try to do it. And then figure out how you pick out the backtracking, the recursion thing. Is then the maybe the other part that's something to think about. Any questions? Okay, what's the next problem? Let's go through this one now. What's the next problem? Stack them up? How many people did stack them up? Okay, and you got it working. Is that right? Anybody have any problems here with this that came to mind? Let's look at the stack them up problem. Somebody who did it, tell me what the stack them up problem is. One of you guys who raised your hand. Somebody who did it. Tell me about the stack them up problem. I haven't talked yet. Or somebody who has talked now. The people won't talk. Somebody talk to me. Tell me about the stack. Yes.
Yes. There is a certain number of shuffle, and then we have 52 cards. Then each shuffle can reallocate cards in a different way. So if we want, we have to check out. If we give you some function of that shuffle, then if cards are putting in those shuffle, what will the results generate?
Right. So the goal here is, you're saying, is we are to read up the input. Again, I look at the input to sort of make sure I understand. Sample input is useful. Okay? First thing to note is that there's an ugly parsing thing where they have this extra blank line. So those of you who didn't understand the thing about how to read things, how did people read the input to get rid of this problem with the other ugly blank line? Okay? Did anybody have any trouble parsing the input of this? Who got it working? They say no problem. Okay? Let's say there's no problem then. What you're saying is we read his input, there were two shuffles. Each shuffle was a permutation of 52 cards written in a 2-line format. Is that right? What does the shuffle mean? Let's just think about that. Okay? The shuffle means, what does this 2, 1, 3 mean? Okay, how do I interpret it? What does it mean?
One means the two of cups, and two means the three of cups, and so on. And it's ordered by the pattern and then other.
Right, okay, so first of all, with this problem thing involved is first there was a initial order of the deck. Is that right? And they specify here what the original order of the deck is. Okay? What these shuffle things are operations on the deck, right? So it's not the case that this 2 refers to the king of clubs or something like that. It describes a rearrangement operation. Is that right? So what does it mean? Because there's 2 different interpretations and I get confused with this. That's why I'm asking. Okay? How do we interpret the first 2 being 1 being a 2? That means what?
Move the second card to the first position.
The second card goes into first position. The first card goes into second position. Right? So this shuffle, it looks like, does what? Okay? What does this shuffle do? Okay? It swaps the first card and the last card. The first 2 cards and the last 2 cards. Does everybody agree with that? What about this shuffle over here? Okay? The second shuffle. What does that one do? Okay? What does this one do? The first card becomes the last one, right? And the last one becomes the first one. Does everybody see that? Okay? That's the interpretation of this. Okay? So for people who got this thing working, how many lines long was your program? You got this one working. How many lines long? 16? 6-0. 6-0. Okay? How many else have got this program working? How long was it?
I use 50 lines for algorithm and 50 lines for outputs.
50 lines for algorithm and 50 lines for output. What about somebody else who got it working? Any other thing? Can't remember. Okay? Let's think about this. How did we represent the array, the deck? How did you represent the deck?
I use
An
an array
array of what? An array of integers was representing the deck.
yes.
So how did you map between an integer and and the card type? What card was in it?
Finally, I will match that and using mod and divide.
Okay, so one thing that's interesting about the way that you did it is that you represented each card as a number from 1 to 52, and then converted between to output it, you converted that to the output format. Another way to do it would have been to have an array of these things themselves. Okay? Who did it that way? Who used a different type of array? Or did everybody have an array of integers? Everybody had an array of integers. That's interesting. Okay? Okay? I personally think the array, you who took 50 lines of output, did you use an array of integers?
Yes. Use switch case. So use switch case for outputs. Spend a lot.
Switch case. Okay. So let's think about that. Okay. How then did you do the so to actually do the shuffle, the deck was an array of these things. How did you implement the shuffle?
Yes. The first two line mentions the function of the shuffle, and then I remember I used another way to store that pattern, and because every number that's indicating the how the shuffle reallocates the card, then for example the first shuffle that's in this they reverse the first and second card, and then the last.
So you had an array of shuffles, basically.
Yes.
It was an array of shuffles where each shuffle was represented by an array
Yes.
of integers.
Yes, and then I use the deck and the previously I create that deck array, and then I just check go through these two shuffle, and then I try to what with the card.
Okay, so the other question here is, I get the idea you have an array of shuffles. You implement a shuffle according to the given specification, right? How many arrays of cards did you have? When you shuffled it, did you shuffle into a new array? Or did you keep it in the original array?
I only use one deck array.
Wait, what?
100, they have the inputs.
You're saying there's 100 shuffles. So you had an array of 100 shuffles. That much I agree on. But I'm now asking something different. When you're actually executing it, just to make sure the question is right, because it was difficult. To execute the shuffle, you have an array of current deck contents, and you're building the next deck contents after the shuffle. Did you shuffle into a blank array, or did you rearrange the array?
I shift to a temporary array and copy back.
You shuffled to a temporary array and copied back. What did you do? Okay? Is there anybody who did not shuffle into an array, a temporary array? Okay? Yeah?
I just rearranged the array. I just do the rearrangement in the array.
You did you get it past the judge?
Yes.
Okay, so you did the arrangement rearranged the thing in an array. Let's see if we understand how you did that, because that's kind of interesting. So how did you do it? Here was your current array contents. Let's say your array was of size 4. Okay? Here is, let's say that there was a deck of size 4, just for purposes of drawing. Okay? These are the contents of the array. You're now going to do the shuffle. What are you going to do? How do you do the shuffle? Implement the shuffle.
Because I'm holding an array of shuffle first, then the array of shuffle holds the new position of the after shuffle deck.
Oh wait, so if what you're doing, you created a temporary array, and then shuffled into the temporary array, and then copied it back? Is that what you did?
Oh, sorry. Yes, I do a temporary array.
Okay.
I've confused my memory.
Okay. Suppose I didn't let you have a temporary array. Would this have been possible? This is kind of an interesting question here. Do you see what the problem is? Okay. What?
No, you can just use all the array of shuffle. You will use one time only. So if you don't use a temporary array, you just renew all the things in the shuffle. Then use the last shuffle array. Is the answer.
Wait, no. I don't know what you're saying here. I mean, the collection of the library of shuffles you have to store. My question is there a way you might have done the shuffling without a temporary array?
And
Yeah.
should we keep the deck in one-dimensional array?
The deck would be in a one-dimensional array, right? So here's your deck in a one-dimensional array.
So we must keep that, right?
Yes.
If so, there's a way to do this, but I think it's kind of more complicated.
I will say it's more complicated, but actually it turns out to be kind of mathematically interesting. Has anybody ever, in the course of taking a course on algebra or anything like that, ever seen anything about the cycles of a permutation? How many people know what I mean by the cycles of a permutation? How many people don't know what I mean? Okay? What's interesting here is that we could, let's say, take a look at this version. Let's say the first shuffle. One way to represent it could be to think about it. is we're putting 1, 2, well, we're putting the first element, we're putting the second element into the first position. Isn't that right? And we're putting the first element into the second position. Right? The third element is staying where it is. Right? Until we got to the back end where we also put around 51 and 52. Okay? What you could have done, and this would have been more complicated, okay? So I agree with you, this is not what I would have done. I would have done it with the temporary array. Okay? But it's interesting to think about this fact that permutations break into cycles. One thing you could have done is to somehow represent each permutation by its cycles and just cycle through each cycle, okay, in the new array. Okay? How many people sort of understand what I mean by that? How many people have no idea what I meant by that? Okay? Maybe with interest of time I won't tell you about that. But I will tell you something that's interesting that's a consequence of this, that's kind of interesting. Why do people shuffle cards? Does anyone tell me this? To mix them up. Is that right? Okay? What is the standard, what is the permutation that would correspond to mixing them up with a perfect shuffle? Okay? What permutation would that be? Okay? One where you took the deck and you split it up. What would the first card be after you shuffled it? 1. What would the second card be? Okay. That's what I'm going to tell you about in a minute. But basically, yes. First, somehow, what would the right permutation be in this language? Is it 1 goes to 1, right? Because take the top half of the deck, right? And let's say we shuffle it. We put the top card first. The second card is going to be the top half of the second one, right? So this would be something like what I think the permutation looks like. Am I right? Let's just think if I'm right. Is it that this is the card that's in the second position is going to be 27? That's the language that they said here. Am I right? Okay. Suppose you took a deck of cards, of 52 cards. You shuffle it with a perfect shuffle. You mix up the deck, right? You then do another perfect shuffle. You mix the deck up more, right? What's an amazing thing is if you took an original deck of cards and you did 8 perfect shuffles, you know what the cards would be mixed up as? They come right back to what the input is. Okay? Perfect shuffles do a terrible job of mixing up a deck. Okay? And understanding why it took 8 cycles, okay, for it to repeat, can be thought of when you look at the cycle representation of a perfect shuffle. Okay? So that's one reason why this cycle format is kind of interesting. Okay? Any questions about what I said? That was meant to be genuine, sort of interesting. Okay? Any questions? Okay? Any other issues on this problem? Okay? I guess the one thing I wanted to talk about, which you guys seem to have done, but I want to just clarify because I think it's an important programming idea, is the idea of using what I will call ranking and unranking functions. So let me come back here for a second. Okay, we know about object libraries. You guys should know about standard template library. We had this discussion about the sorting. The reason why the sort came easily is because you had included the standard template library. Okay? So one thing I strongly encourage you, if you don't yet use it, is learn about the standard template library. And that'll give you access to structures like stacks and sorting and things like that. That's important. But there's one programming idea that I find in designing algorithms, well, in programming lots of things, turns out to be a useful idea. is the idea of creating what I will call ranking and unranking libraries, functions, between different things. So what do I mean here? A hash code, you know about hash functions. A hash function maps a thing to an integer in a way that many things can be mapped to the same integer. That's a collision. A ranking function maps each element in a given set to a unique integer. Okay? Where there is no collision. Okay? And sometimes what I can do is, in certain universes of problems, I can write a function that takes a class of objects, computes a rank function to get a numerical value of it. Okay? And an unranked function that takes me back from the numerical object to the original one. Okay? So rank and unranked functions come in pairs. That's the important point. Right? And if, for a class of things, okay, you can come up with a function such that rank of s, unrank of, rank of s is always equal to s, then you can use the numerical thing as an equivalent representation for the object. That's the value of this thing. Any questions? So where might I have used this thing? When I was building a program to deal with playing cards, okay, just like you were dealing with things in playing cards, in some sense you did something like that, right? You represented each card as a number from 1 to 51, or perhaps 0 to 51, right? And you said you were doing things with mod and div and stuff like that. What you were really doing was constructing a mapping between the original order of the deck, okay? Or not the original order of the deck, the name of a card, okay? And its numerical value, okay? And this is a powerful idea, okay? You can do it for permutations. There's n factorial permutations of things. Sometimes you'll worry about permutations. If so, you could represent a permutation as a number between 1 and n factorial. Okay, there's 2 to the n subsets. You could represent every subset by a distinct number from 1 or 0 to 2 to the n minus 1. And it's often nice to be able to move back and forth between these representations. Okay? What can you do if you have a ranking function on an object? I find you can do these things very easily. What if you want to construct all of the objects? How would you do it? Suppose I want to print out a list of all the playing cards. How would I do it if I had rank and unranked functions? Okay? 4i goes from 1 to 52. Unrank I. And now I've got the string corresponding to the playing card ID, right? So that's one thing I can do well with a rank thing. Suppose I want to pick a random card. Let's say I want to be a 3-card Monte dealer or something like that. I want to write a program to play a game. How do I generate a random card? Okay? Pick a random number from 1 to 52 and unrank it. Does everybody see that? What if I want to take 2 decks and decide if they are, which one is stronger or not? Let's say maybe like in comparing poker hands. Here might be an interesting thing, right? In poker hands, certain properties beat other properties, right? To score a hand, if I had a way of reducing each card to a number, where a higher numbered card was ranked higher, it might be very, very easy to score my hand, okay? Or if I wanted to figure out if 2 hands were the same thing, I would take the cards, sort the number, rank them for the numbers, sort them, and then compare them linearly, okay? So ranking and unranking are good things to do, okay? And any questions about this idea? Again, in my problem, in the book, I had built, again, you guys seem to be ahead of me. This is how I built a ranking function for cards that may, by the way, not be suitable for what you would have to do in your assignment. Okay? Here, again, basically I had an array of the possible value codes, an array of the possible suits, okay, to identify the suit for a card. It was card mod, the number of suits, okay? To identify the value of the card, it was card div, the number of suits, okay? Because in my ranking function, what does this mean, imply about my ranking function? Okay? It would say that the 0th card, the lowest ranking card, would presumably be the 2 of clubs, okay, by my scheme, right? The next highest value, what would card 1 be? Well, the div wouldn't change, right? But the mod would. So that means that the second highest ranking card by my model would be the 2 of diamonds. Does everybody see this? Okay? And here you can see where I had given a card, a value suit pair. I ranked it. Okay? Okay, and maybe I even did more work than I need to do. So I did some error checking. Okay? Any questions about this? This ranking and unranking are useful things to do, useful ideas. Any questions? Okay. Last problem I want to talk about today is the Yahtzee problem. How many people got Yahtzee? How many people have been playing with Yahtzee? How many people tried Yahtzee? 2 or 3. How many people got it working? You got it working, although you didn't try it. Oh.
You mean to try the game or?
Oh, okay, no. How many people tried the problem? How many people tried the problem? Okay? Raise your hand if you tried the programming problem. Okay? How many people got it working? You did. Okay? Let's think about what our problems are. What is the Yahtzee problem? Somebody who read it and tried it. Okay? Anybody else? Anybody? You've become my designated reader today. Go. So what's this problem?
You have 13 tries of throwing dice, and you have 13 methods to score them. Then you have to have a sequence of score method which have the maximum score, possible score.
Okay. So again, we've got 13 sets of cards, of dice, 13 rows of dice. There's 13 possible categories, right? Each category card scores a certain amount according to each set of 5 dice scores a certain amount in each category, right? And your goal is to pick which is the category to assign to each hand in order to maximize your score. Is that right? Okay. Are there any parsing issues or anything like that that comes up here? Not really. It looks pretty simple, right? Or maybe. Do people have any issues with parsing? Now the question is, algorithmically, this seems like a hard thing now. How do you assign what category goes to what dice hand? So everybody see that's really what the hard part of this problem is? Okay, any ideas how you do it?
Dynamic programming.
What?
Dynamic programming.
You use dynamic programming, which we're going to talk about in here later on. Okay? So if you don't know about dynamic programming, don't immediately panic. Okay? You won't get this problem maybe if you had to do it by dynamic programming, which I don't know if you have to. You're saying what did dynamic programming mean? Tell me what that meant.
You can represent every state, which when you finish the first n
method to choose car, and how and what the
So what it sounds like what you're trying to say is maybe that you're going to try to figure out what's the optimum solution using the first. Well, actually, wait. I don't know what the state of your dynamic program is yet.
I explain it.
You want to write it or not, or you don't want to bother? Okay, let's go try it. Okay, go pick one.
It means we finish first I
First I categories, right?
And J means
First J.
means the state. Set of car.
Set of hands.
Set of
Dice hands.
used.
Okay. So you're saying you computed what was the optimal score on the first I categories?
J is a binary number. It is 13 digit.
Oh, okay.
And 0 means used and 1 means no. 0 means
Okay.
unused, 1 means.
So I think I'm seeing what he's saying here. So what he's saying is he will have used a subset of the dice hands and a subset of the categories. Okay? And he wants to know what is the best score possible with that. Now, obviously in one sense he's right, because the right answer is going to be the value of f sub 13, 13.
No.
Right? F sub 13, all true.
13 and
All true. Right? Okay, it's 2 to the right. Okay? I'm not sure. Okay. That would be okay. And so the question that was more subtle that we won't get into right now is how do you maintain this? Okay?
use the operation.
Okay. I see. And what you're really saying here is that the way that you would enlarge it is if I am going to have a certain set of categories and a certain set of hands and a certain set of categories, okay? If I want to do a larger one, if I add another hand to this set, my optimal way of doing it is going to involve getting the answers to certain smaller ones and aggregating over that. That's the dynamic programming part, right? You're starting out with all hands of one, all instances with one hand in it, right? One hand in one category.
0 is can start with 0.
0, and then you're building. Okay, so I understand what you're doing now. Okay, I don't know if anybody else does, but I understand it now. Good. How did you do it? Who got it working? Who else got it working? Well, how are you going to do it? Who was going to try it?
I cannot get it work because first I tried with brute force, but
Okay, so brute force and what happened? Okay.
it have a very long loading.
Okay, so
time.
let's think where we are on this problem, because this is we're after running out of time, but there's a couple of solutions here or approaches here, and there's a couple that are not here. One idea was to try all possible things, okay? Where if all possible was too large, if you said I'm going to try all possible mappings, that's 13 factorial. That's too large, because 1,000,000 is what you can naturally do, right? I think if it's 1,000,000 it's being reasonable. 13 factorial is much bigger than 1,000,000. 2 to the 13th is how much? 2 to the 13th looks like a big number, but what's 2 to the 13th?
8,000.
8,000 is not, right, that's less than 1,000,000. So this doesn't scare me. That might be a reasonable way to do it, right? Another way to do it might be to use a heuristic to reduce it down. So certain of the categories, I'm not sure this is a good way to do it, certain of the categories you probably could assign pretty well because it never paid for you to use the 4 of a kind or 5 of a kind category unless you had 4 of a kind or 5 of a kind. Does that make something? So one possibility might be a less brute force way to do it. Okay? The other was to use dynamic programming. And there's at least one other way to do it. Does anybody have any idea? Okay? Yeah?
You could use like a search of some sort, but then it'd be a lot of code, so I would.
Well, by search, that sounds to me like brute force. Is that what you mean, or what do you mean?
Like an A-star search with a heuristic, but that would be a lot of.
Okay, so that's sort of what you're saying here is brute force, but clever brute force, backtracking-like thing. That's what I interpret that as being.
Yeah.
Okay? And that might be a reasonable way to do it, although it's potentially risky. Any other ideas?
I do not think when the heuristic will work because there's a bonus. Very boring here.
I see, there's a bonus. What is the bonus?
Bonus here means the first 6 is more than.
Ooh,
so
okay,
heuristic
okay, that's an interesting idea. The bonus is seemingly, right, okay, that may make a heuristic not work so well. That might complicate it, you're right. That also might complicate the idea that I had. I'm going to say this very quickly, because I think if we didn't have the bonus, what about bipartite matching? For those of you, how many people here know about bipartite matching? Raise your hands if you do. Very few of you might, okay? If you don't know, don't worry about it. But what we could have done, if we had the weight of each permutation, right, of each dice thing, and the weight in each category, what we really want to know is, what is the matching between permutations and categories of maximum total weight? Does everybody see that? If you did it that way, you could call a bipartite a maximum weight matching thing, and that would solve it. Although I agree with you, the bonus thing is a problem. Okay? Any questions? Okay? So let's say, think about that. Try to do the ones that you can. If you're scared by the talk of dynamic programming, don't worry. Get the other ones working. Okay? Do the best you can, and we'll talk more about this next week. Any questions? Thanks a lot. See you guys next week.